move to talking about the cardiac output, and this is basically how much blood is ejected from your ventricle with time, okay? So do not confuse cardiac output with stroke volume. All right, so stroke volume is how much blood is being squeezed from that ventricle, right? But cardiac output is how much blood is leaving that chamber, leaving that ventricle per minute, right? So it's a product of stroke volume and heart rate. Okay, so how much blood are we pumping out in every heartbeat per minute? Okay, now that's gonna have to do with your stroke volume, which is what we talked about, but it's gonna be inclusive of the time, the heart rate. How fast is that ventricle beating? All right, and that is going to give us your cardiac output. Now, the average cardiac output is about 5 liters per minute at rest. So as you're sitting here in your chair, in every minute, your heart beats 5 liters, right? Your heart moves 5 liters out into your system. Okay, and every minute at rest, this is not even walking or running, your heart is moving 5 liters out into the systemic circulation. Now, how much blood do you think is in your entire body? How much blood do you think is in your, right? So it's 5.5 liters, right? So your entire blood volume is 5.5 liters. So what does that tell us? What does that tell us? Right, all the blood in your entire body goes through your heart in every minute, right? And that's sitting quietly at rest, all right? If you start running, then you're gonna double up that number. What we're gonna talk about today is factors that affect the heart rate, so your factors that affect the cardiac output, so your heart rate and your stroke volume. And we're gonna talk about the things that affect the heart rate first, and then we're gonna look about things that affect your stroke volume. Now, the heart can be regulated either intrinsically or extrinsically, right? Now, when we say extrinsic regulation, these are external factors such as nerves and hormones that can affect the heart rate and the stroke volume. These are extrinsic factors, factors that are not within the heart itself. What nerves did we just talk about that influence the heart rate? Your parasympathetic and your sympathetic nerves. So that's the neural input which influences your stroke volume and your heart rate, which then is going to influence your cardiac output. There are also some hormones that we're going to look at, such as glucagon, which naturally increases your heart rate, and that is going to have an effect on your cardiac output. Then there are some intrinsic factors, and this means that the heart has mechanisms in and of itself that can regulate the heart rate and regulate the stroke volume. So this is what we call autoregulation, which means regulating yourself or regulating itself. So the heart has certain mechanisms, and we're going to talk about one specific one later on, which is basically how the heart can regulate its own rate, its own stroke volume, its own cardiac output. All right, now when we look at the autonomic influence on the heart, we already talked about this. There's the parasympathetic influence and the sympathetic influence. The parasympathetic influence is going to be coming specifically from the vagus nerve. All right, so the influence of the parasympathetic system on the heart is specifically from one of those 4 nerves we talked about, right? That cranial nerve 10, which is the vagus nerve. All right, now the vagus nerve is only going to influence the SA node and the AV node, okay? It's only going to influence the SA node and the AV node. It's not gonna have a very significant influence, in fact, almost none, on the ventricular contractile cells. It's only going to influence those pacemaker cells, right? The sympathetic division, on the other hand, this is coming from the upper part of the sympathetic trunk, right? Remember the structure, the sympathetic trunk. The upper fibers here is going to influence the heart, and they're going to innervate the SA node, the AV node, and the ventricular myocardium. So they are going to influence the contractile cells of the ventricle. Right, so I'll reiterate that. The parasympathetic fibers do not influence ventricular contraction. They do not innervate those contractile cells. Only the pacemaker cells of the SA